Hi students, since I had a reading quiz actually made, you're not graded on this, but I wanted to kind of go through this with you if you wanted to review it after you read it. So a couple of things. The first question is contrast autotrophs and heterotrophs. So if you want to go through each question, you can either say it out loud, you can write it down. I'm kind of going to do the same style that I do in class where I'll just go through all 6 questions and then we'll go through the answers. So if you wanted to write them down or if you just wanted to say them out loud to yourself, that is no big deal. So contrast autotrophs and heterotrophs. So contrasting, I want you to say, what do autotrophs have? What do heterotrophs? What are the 2 differences between the 2? Where in the chlorophyll, where is all the chlorophyll kept in the plant cell? So where is all of that chlorophyll kept? Be very specific for full credit. For full credit, you would need to tell me the 2 places that chlorophyll is. And question number 3, the carbon for photosynthesis comes from blank molecules. The O2 produced in photosynthesis comes from blank molecules. Can you answer this question without looking at your notes? It might be a good helpful thing to maybe try it without your notes in general, but that is what we are going to do. Number 4, can you list the 3 inputs and the 3 products for the light reactions? What are the 3 inputs and what are the 3 products for this? For the light reaction. Can you, for the question number 5, can you list the 3 inputs and the 3 outputs, 3 inputs and 3 products of the Calvin cycle? Hint, the Calvin cycle comes after the light reaction, so maybe your products might be your 3 inputs for the Calvin cycle, or some of those might be related. Question number 6, if shared electrons in the glucose molecule are closer to carbon than they were in the reactant molecules, you could say that the carbon is being blank. Okay, if you want to, you can pause this and go through, answer some of those questions again, but here we go. I'm going to go through the answers with you. Obviously, you don't need to take a picture. I'm just going through the questions. Contrast autotrophs and heterotrophs in order to get full credit for this question, or when you are taking the AP exam, make sure you do your contrast of both things. Make sure you're stating both of them. So autotrophs produce their own organic food. They perform photosynthesis. Autotrophs produce. Auto, think of what auto means. They are doing it themselves. They are producing their own. Heterotrophs consume food made by others. So heterotrophs are consuming that food made by autotrophs. So what would you consider us? Are we heterotrophs or autotrophs? We're going to be heterotrophs. Question number 2, where is all of the chlorophyll kept in a plant cell? We're going to be very specific with this question. A quarter of it is in the chloroplast, but most of it is held in the thalcoids, or the thalcoids. So that is where your credit is going to come. Remember we talked about those stacked pancakes? That is where the surface area, this is a great picture shown here, that the surface area, they're the stacked, the thalcoids are the stacked pancakes on top of each other. Look at all the surface area involved in this in order for photosynthesis to happen. I don't know why we needed that sound, but we got it. Question number 3, the carbon from photosynthesis comes from blank molecules, and the O2 produced in photosynthesis comes from the blank molecules. What are they? If we think of this was shown in class today if you stayed with us. Where is the carbon coming from? Where is it going to? That carbon is carbon from photosynthesis comes from the CO2. It's coming from the atmosphere. The O2 produced in photosynthesis comes from the breaking down of the water molecules. This would be a great slide to maybe take a picture of, to write it down in your notes. This would be very helpful. Oh, that's not very big on your thing. Let me see if I can make this bigger for you. I can't. I'm going to drag this down here so that you can see it. So that's your bottom reaction here is your C6H12O2 is your products with water and O2. Sorry, that got cut off there. Next slide here, list question number 4, listing your inputs and your 3 outputs for each of the light reactions. This is a 6th point for each one. So what are some of your inputs? We're going to have light is going to be one of them. Maybe light will be one of them. Light is going to be one of them. What do you need for your light reaction to happen? We need light. What's this blue blob at the top here? That's going to be your water, your H2O. And the other thing we're going to need is NADP+. We're going to need this in order for your light reactions to happen. The products that are going to come out, and we have ADP as well. So those are 4. You only needed to list 3 of them. Your 3 products are going to be your O2, this red bubble that's here on the bottom, if you look at that. And then it's also going to be ATP. And then what's this box going to be? This box we brought up with the 2 negatives here at the top. We saw this in the reaction done by cellular respiration, and you should come up with NADPH. Nice job. So now we are looking at listing the 3 inputs and 3 products for the Kelvin cycle. The first one that we are going to do input is going to be your CO2 from the atmosphere. It's this gray thing here. And the next thing that we are going to need is we are going to need this ATP that was produced from the light reactions. Similar, just like what happened in the cell respiration, we need this ATP that was produced from the cycle before in order to produce the most amount of ATPs in that Kelvin cycle. And if you notice, the Kelvin cycle is happening in the stroma. The next one is we're going to need that NADPH. So these products, these inputs here, products of the light reaction are part of the inputs for the Kelvin cycle. The 3 products that are created is our sugar. Let me see here. This slide is so big that I can't. So here's our sugar, our ADP, and then what is produced here at the top? What's needed for the light reactions? We take a second. What is produced is our NADP positive. So we're taking our NADPH and creating NAD positive. So this is a cycle. This is our circle of life. So each one of them cycles within themselves in order to create the overall big cycle. Question number 6, the last one, is if shared electrons in glucose molecules are closer carbon than they would react. This would be an example of GER. They're gaining electrons. They are gaining those electrons, so they are reduced. In the redox reactions, these are being reduced. So I hope this helps. Let me know if you have any questions. So this was the quiz that we would have gone through together as a class. And happy learning.